This is a map of the planet's average annual temperatures compared to the historical temperature record. To do this, all the temperatures recorded throughout the year in all areas of the Earth are calculated. The annual average of each site or pixel is calculated, and finally, this annual average is compared with the average obtained between the years 1951 and 1980. If it has been colder than normal, blue. If it has been warmer, red. This is super useful for analyzing the long-term trend. 3 areas stand out clearly on this map. Most of the world, red, global warming, nothing new under the sun. Antarctica, blue, thanks to the upwelling of a very cold deep water reserve, it is managing to stay somewhat isolated from the warming. And in blue, also the cold spot in the North Atlantic. This spot has been appearing on maps for several years now. But it wasn't until a few days ago that a study came out with enough evidence to clarify its origin. And unfortunately, out of all the possible hypotheses, we've ended up with the worst one. This, although it's directly related to climate change, doesn't work the way most of the climate change consequences we're used to reading about in the media do. The cold spot, yes, that's the official name of the phenomenon, could have almost immediate effects. We're talking about just a few years. And with differences in temperatures, precipitation, and so on, much more noticeable than standard climate change, so to speak. Before we get into the specific data, we need to understand the cause of all this mess, the AMOC, by its initials in English. A system of ocean currents that are very important for the planet's climate, among which is the famous Gulf Stream, which, although very well known, does not determine everything on its own. It depends a lot on the other currents. To give you an idea, the AMOC transports 1.2 petawatts of power, which is equivalent to 1.7 million Hiroshima bombs in a single day. 20 Hiroshima bombs per second. It's titanic. And as you may already know, it's a key factor in why Europe is a continent with such a mild climate, despite its high latitude. This map overlays European cities on North America. Barcelona, despite being further north than New York, has on average between 0 and 1 day of snowfall per year, while New York has 12. And in Barcelona, the snow almost never sticks. The last decent snowfall was in 2010 when Instagram didn't even exist yet. In New York, this happens several times a year, and that's even though the American city is further south than the Catalan one. Although the most spectacular comparison of all is between the Russian port of Murmansk at 68 degrees latitude and the Canadian port of Churchill on Hudson Bay at 59 degrees. The Russian one, much farther north than the Canadian one, literally inside the Arctic Circle, doesn't close even in the coldest months of the year, while the Canadian one, much farther south, has to close for 8 months a year because the water freezes. AMOC is one of the phenomena on the planet that has most influenced all of human history. The prosperity of Northern Europe is largely thanks to this. We're talking about a region that, despite having a great abundance of natural resources, should be frozen during the winter months because of its latitude, but instead it enjoys very mild winters, ports that don't freeze, and long growing seasons. An anomaly that allowed for dense agriculture and maritime trade networks that operated year-round, laying the foundations for medieval expansions and, later on, the Industrial Revolution. Alright, but what does the patch have to do with this? Well, the thing is, in general, we don't like patches on maps like this because they can imply that there are imbalances. The one in Antarctica is a tolerable exception because the frozen continent represents what was normal, a vestige of how things were before climate change. But if we're talking about an AMOC imbalance, which is right in the area of the spot, things are about to happen. It's important to mention that since the spot appeared, the main hypothesis to explain its existence wasn't AMOC, but a very different one, that of changes in atmospheric patterns. For example, the fact that the number of clouds in that area of the ocean had increased could have blocked solar radiation and cooled the surface. But this is where the study from a few days ago comes in. It's the first one that tackles the problem using not only climate models and predictions, but also a lot of real data. In a very simplified way, it found that not only is there no cooling caused by the atmosphere, but actually quite the opposite. It has warmed the water of the North Atlantic more than usual. If even so a cold spot has appeared, the only alternative is that AMOC has severely weakened and its collapse could be imminent. This is what has happened. AMOC normally collects warm water from the east coast of the Americas and the Caribbean Sea, transports it to northwestern Europe, where it releases it. By then, it cools down, increases in density, sinks to the depths, turns south, and returns to the beginning. It's important for you to understand that it's a closed loop. What has happened in recent years? Well, the fresh water coming from the melting of Greenland and polar ice has significantly altered the density of the water in that area. Let's remember that salt water and fresh water have different densities. This has significantly altered the mechanics of the current, which is precisely based on that delicate balance of densities. In addition, the atmosphere, which as we've just seen has been warmer, has further altered that density by heating the water. Essentially, both factors have for several years prevented the water from becoming dense enough to sink. This causes an interruption of the current, which weakens and slows down, and therefore doesn't have enough strength to carry the heat to Europe. That's why, in the long term, the area of the patch cools down and we see it appear on anomaly maps, since for decades it was receiving warm water and now suddenly it's not. The most delicate point is that ocean currents are like rivers. If they're interrupted at any point, everything overflows and the course changes or is lost forever. Forever. Until a few days ago, this whole scenario was just a hypothesis, since we didn't know if it was really what was causing the patch. Now it's a reality. But since the patch has been occurring for years now, the risk of imminent collapse is higher than when it first started forming. AMOC hasn't been able to flow normally for years, and this escalates exponentially. Once the collapse is triggered, everything happens very quickly. How fast and how serious exactly? Well, since this study is fresh out of the oven, there haven't been any studies yet that recalculate the predictions that were already made with this new reality. There are experts who place it starting in 2100, but others say it will happen in the middle of this century. If this ends up being the case, almost all of us are going to experience it. With AMOC collapsed, Europe's temperatures plummet. Oslo, the Norwegian capital, goes from winter lows of 15 degrees to minus 48 degrees, and for 46% of the year, almost half, the highs don't go above 8 degrees. Something very similar happens throughout Scandinavia. Further south in the Scottish capital, Edinburgh, it goes from lows of 1 degree above zero to minus 30. The sea ice would reach as far as Belgium, even France, and so on. And that's not all, it affects the whole world. There will be a weakening of the monsoons, both African and Indian, which means drastic reductions in rainfall in these areas where most of humanity lives and needs that water for food. There would also be an additional rise in sea level along the entire Atlantic coast of the Americas and in Europe of about 50 centimeters, which would be added to the much slower rise from the rest of climate change. And all the cold that would no longer be sent down would cause a significant warming of the southern hemisphere, which would add to the usual global warming. The good thing is that this is the final state, about 150 years after the collapse begins, since this, although instantaneous on planetary time scales, exceeds the average human lifespan. However, everything starts to be noticeable from the day of the collapse. For example, in Norway, the average temperature would drop by 3.5 degrees per decade. It's a much faster rate than what we're used to with global warming, which is about 0.2 degrees per decade. And even though it seems paradoxical that one part of the planet cools down during a state of global warming, the overall trend is still warming. The cooling would only affect Europe, and the rest would warm up even faster than it already is. But hey, calm down. I also don't want you to think this is extremely serious after watching this video. Personally, I've always thought that, although it's important to raise awareness about the changes our planet's climate is experiencing, catastrophic narratives, and especially those that are exclusively negative and overly pessimistic, don't help at all. In fact, I feel that they end up causing most people to reject the issue, making the public disconnect even more from the topic. So, since I don't want you to leave with a bad taste in your mouth, here's a bit of positivity. On the one hand, I'm sorry, but you'll probably be long gone by the time the effects of the AMOC collapse start to be truly severe. And on the other hand, 150 years is a long time for science and technology to get ready to deal with them. Besides, if current fertility trends don't improve quickly, the human population worldwide will soon enter a severe decline, so there will hardly be any supply problems when it rains less. Worry, but only a little. and use that worry not to fuel negative thoughts, but to create the tools that will help your grandchildren while you enjoy life. Thanks for watching the video. Goodbye.